And what I normally do once we start the recording, what I typically do is I will go ahead and shut my camera off, because that way it streams a little bit better if I don't have my camera going when we do our PowerPoint presentation this morning. So again, welcome everybody today. Let's go ahead and we'll pull up our presentation on our HMH7 SEER heat pump. And Tony, I'm going to let you kind of be the scribe like you always are. Make sure that the screen is looking good and all that, and then we can as we move along, make sure everybody can see the screen okay.
Yeah, we're good to go, Joe.
Okay. All right, so there's our home screen. Can you see that okay, Tony?
Yep.
And I'm going to also let you, if you don't mind, Tony, I'm going to let you also kind of man the chat box as well. If anyone has a good question, they can either unmute their mic and ask that good question as we move through the program today. In addition, you can also hit your little chat box, and Tony's going to monitor the chat box. So if you have a question, just type it in the chat box. Tony will read it out, and then we'll go ahead and answer those questions throughout the program.
Yeah, and I'm going to go ahead, Joe, I'm going to go ahead and put the training catalog quick reference in today's chat. And if any of you have difficulty with that, it'll be an attachment. You should be able to open it and save it on your computer. And in addition to what Joel mentioned, as far as the his YouTube channel, there's also, it's a catalog of our other training that's in this document. So I'm going to put that in the chat. If you have problems with opening it, let me know and I'll email it to you, okay?
Man, that sounds good, Tony. Thank you for doing that. Okay, team, well, let's go. So this morning, let's talk a little bit about the HMH7 SEER heat pump. And you're going to notice as you take a look at the heat pump, there's going to be a couple different platforms or footprints, if you will. The dead giveaway, if it's a 2 or 3 ton unit, it'll just have a single fan. And if it's a 4 and 5 ton unit, it'll be the 2 fan model. So just remember that the 2 fan model will be the 4 and the 5 ton footprint. We're also going to ask that you please remember that the unit service fittings are 5/16 inch flare, and an adapter will be required to adapt your service hoses, your 1/4 inch service hoses, to these units. Now, these units kind of look like mini splits, and they use that same 5/16 to 1/4 inch flare adapter. Kind of see the little picture up there in the left-hand corner. But let me stress, these are not mini splits. Let me say it one more time and stress it again. These are not mini splits. They're regular heat pumps. You just run a suction line, you run a liquid line like you normally do, install a bi-flow filter dryer on the liquid line, because their heat pumps will need to filter that liquid in both directions. And you just treat it like a regular heat pump. On the indoor coil, and air handlers, and they're just a very, very versatile unit. But please remember, the technicians will have to have this adapter to adapt their service hoses from 5/16 down to the 1/4 inch service hose. And by the way, those adapters are very readily available. I think Robin Air and Yellow Jacket and some other companies make those. As a matter of fact, if any of our customers out there are utilizing mini splits, or if they're working on mini splits, they probably have a pocket full of these adapters anyway. They are the same as a mini split, even though these units are not mini splits. I like to stress that a couple times. A couple other good questions that we get quite often when we're talking about the product, as a quick overview, is, at what temperatures will this thing work down to as far as in the heating mode of operation, and what's the minimum cooling for outdoor temperatures? So this little chart right here is right out of the install information. As you can see on the outdoor coil, in the cooling mode of operation, it'll go all the way down to 35 degrees in the cooling mode. And the maximum outdoor temperature is 122. That's what it's rated at. And in the outdoor coil, the minimum heating is -5 degrees. Maximum is 75 in the heating mode of operation. And then you can look over there in the cooling as far as the wet bulb cooling and heating as well. So there are some min-max temperatures on the thing, but as you take a look at that chart a little bit closer, you'll see they're quite broad, and they're quite aggressive as far as, when the thing will operate to. And let's face facts, once you, on any heat pump, once you start getting down below about, 15, 20 degrees, it starts losing capacity quite a bit, and you'll probably be bringing on some auxiliary heat typically. But it will operate all the way down to -5 on the outdoor coil in the heating mode of operation. And you can also use it to heat the home up to 75 degrees outside, which is going to be pretty warm outside to be running a heat pump, but it still has that flexibility and capability. Hey team, at this time we're going to be discussing low voltage wiring and the setup of the HMH7 heat pump. And we're going to be we're going to start out with an AE air handler, which features just a standard ECM motor. Now, anytime we see, in our Johnson Controls literature, standard ECM motor, that's the old X13 type of motor that we call a standard ECM motor. It's been enhanced over the old X13 motors. They're a lot more reliable than they used to be. And these are the high efficiency motors that have the speed taps on them. They'll have like typically 5 speed taps, 1, 2, 3, 4, 5. So that's the motor that we're talking about. We're going to get into the low voltage wiring on that AE air handler, and we're going to be looking at a simplified block wiring diagram. Now, please remember the AE air handler has no physical hard screw-on terminals, but is equipped with pigtail connections. Now, in my block diagram, I show our thermostat wires landing on a terminal. Just please remember they're pigtails, but for ease of putting things together in the PowerPoint, we're just showing terminals, even though they're actually pigtails. In addition, we're going to talk about wiring of the accessory single pole double throw relay in the indoor unit and how it's going to be used for airflow reduction. We're going to recommend kit number HMH7AK001 for convenience and supplied parts. Now, what I mean by that is this: for convenience and supplied parts, this HMH001 kit, what it has inside there, it's got a biflow filter dryer in the kit. It also has the relay pack or the relay board. In addition, it also has some wiring pigtails to make it easy to hook things up quickly without having to manufacture field supplied spade connectors and wire and all that kind of stuff. So it is recommended. Now, the obvious question comes up. Well, gee whiz, Joel, what happens if we can't get a hold of that kit, or, our local wind supply company is out of them or whatever? And, what do I do to hook this up? Very, very simple. Just grab any 24-volt coil, single pole, double throw relay, and you'll have to manufacture some field wiring as far as, spade connectors and stuff like that. But you can use a standard peanut relay, and I recommend a sealed relay, but just a standard little peanut relay, single pole, double throw action, 24-volt AC coil, and then you can provide your own biflow filter dryer if necessary. And so please remember that this is recommended. Our kits are recommended for convenience and all the supplied parts, but if you have to field manufacture, in other words, if you just need to buy a relay, a little peanut relay and a biflow filter dryer and make up all the wiring, it's no big deal. You can do it in the field if you need to. It should also be noted that the HMH7AK002, the 002 relay kit, may be used. It actually has 2 relays on the board. However, the RV relay will not be needed for this particular application. So I like to consider the 002 relay kit really as kind of a universal relay kit, in the fact that it has 2 relays on it. And if you need to, you can use that kit because you're only going to be using one of them on the AE air handler in this example. So the 002 kit has to be used for variable speed products, but it can be used for other products as well. So like I said, I kind of consider it a universal kit. So either way, be sure and get those kits when you're installing the equipment, or make up your own kits if you need to, with a single pole double throw relay and a biflow filter dryer. It should be noted also on the HMH7, unlike our other heat pump products in our Champion lineup, the HMH7 utilizes the B terminal on the thermostat to energize the reversing valve in the heating mode. It's exactly opposite of all of our other heat pumps. It's not bad, it's just different. So please remember, your heat pump thermostat has to have a BO selection for reversing valve operation in the heating mode. Any questions or comments so far before we start jumping into some block diagrams and talking about how to hook these things up? Everybody good? Okay. All right, at this time, let's go ahead and take a look at a simplified block wiring diagram of the AE air handler with our HMH7 heat pump. So starting at the thermostat, We're going to take that B terminal from the thermostat and take it straight outside. Now remember, team, that B terminal is going to be energizing the reversing valve in the heating mode of operation, Another way of thinking about it is that the default mode on the HMH7 is cooling mode. So the default mode is cooling mode, and you're going to energize the reversing valve in the heating mode of operation. If you have a two-stage heat strip, W2 from the thermostat is going to go to W2 on the AE air handler. You'll just make it up in that pigtail, your W2 to W2 on your thermostat to your indoor product. W1 is your auxiliary heat strip of first stage auxiliary heat. And so you're going to carry that outside as well. Now, please remember that on first stage auxiliary heat, the thermostat can energize first stage auxiliary heat, but also you'll notice on the outdoor unit, we have a W terminal on the outdoor unit. That's to bring the heat strip on, that first stage of heat strip during defrost. Because remember, team, whenever a heat pump goes into defrost, it goes into the cooling mode of operation to defrost the outdoor coil. And it's going to be blowing cold air in the space. So we bring on some heat strips so we don't, freeze the homeowner out, or more specifically, we're tempering that air in the defrost mode of operation. Y terminal goes out to the compressor. That's our Y signal from the thermostat to the compressor. Now, please note something. Even though the HMH7 is a modulating unit, it'll modulate from 35 to 100% capacity. It's so simple to hook up. That's one of the reasons I really like this thing. All you have to have is a single Y terminal outside. We don't have a Y1, we don't have a Y2. It's just single Y terminal going outside. And then the outdoor unit makes intelligent decisions by looking at suction line pressure, suction line transducers as far as pressure and temperature, suction line sensors, liquid line sensors. So it's taking a look at the refrigeration circuit and monitoring the refrigeration circuit. It's also monitoring outdoor ambient temperature. And it makes intelligent decisions on when to modulate with just a simple single Y signal going outside to call for compressor operation. I think that's just one of the coolest things around, is the fact that this unit is so simple to hook up, but it's got just a lot of features and a lot of comfort capability. You'll also note that on the AE air handler, you may have a yellow factory wire on the ECM motor. If that's the case, be sure and remove that yellow wire from the ECM motor, because we're going to be doing some different things with the speeds on that motor. So if it is equipped with a yellow wire on the ECM motor, please remove that if you have that yellow wire from the factory. C is our 24-volt common, and you'll notice that C terminal goes all the way through from the thermostat to the air handler to the outdoor unit. That's 24-volt common, goes all the way through. The R terminal from the thermostat goes strictly to the indoor unit. Now, let me repeat that one more time. The R unit does not go outside. It goes from the thermostat to the indoor unit, but it does not go outside because the outdoor unit does not require an R terminal like all of our other products. So we're not powering up the board, so to speak, outside with the 24 volts from the indoor unit transformer. So we do not take R outside. Terminal is our fan call. That's very, very standard in the industry. So you have G from the thermostat right over to the indoor product. Now, before we start talking about how to wire that relay up and stuff, is there any questions or comments so far on our low voltage block wiring from our thermostat to the indoor unit to the outdoor unit so far? Everybody good? Okay, good. Well, let's go ahead and start talking about that relay then. So one side of that relay coil, one side of the single pole double relay coil is going to go up and attach to S1. So when the outdoor unit has the capability, or when it's going to command reduced airflow, let's say when it gets down to like 50% capacity or 60% capacity, it's going to energize that relay, that single pole double throw relay, and it's going to reduce the airflow inside to more accurately and to more closely match its point of modulation or capacity reduction. So one side of our relay coil is going to go up to S1, and the outdoor unit is going to generate a 24-volt signal when it's time to reduce airflow. You'll notice with the relay just sitting there unenergized, though, the contacts haven't moved, and If we do not have an S1 signal, the relay is just sitting there in its unenergized state. The other side of that relay coil is going to go up to 24-volt common, which makes sense because it's a 24-volt AC coil on that relay. Now, the common terminal of the switching contacts, we're going to make up on the yellow wire so that anytime we're calling for compressor operation, we're going to energize the common terminal of the switching contacts. Well, notice on the ECM motor also what we're going to do before we hook up any of the normally closed or normally open switch functions on the relay, we want to make sure that we grab the high-speed tap and on the high-speed tap on the ECM motor and hook it on to the W1 or the first stage auxiliary heat terminal. And the reason we do that is anytime we go into defrost mode or anytime we call for auxiliary heat, we're going to drive that indoor fan motor to speed tap number 5 to make sure we have plenty of airflow. We don't want to overheat the heat strip when we go to auxiliary heat, and we just want to make sure that we have adequate airflow. So typically, the most common spot to put that number 5 speed tap on that ECM motor is up there on to our W1 or our auxiliary heat terminal. Now, as we take a look at that relay, let's take our normally closed, we're going to take the normally closed contact on the switching relay, and we're going to go over it and we're going to select a speed tap on the ECM motor to provide 100% cooling airflow. And so what we're going to do, we're going to, whatever speed tap we select. Now remember, team, on the ECM motor, once we get the thing installed and we get our ductwork all hooked up and all of our registers are wide open, we're going to start the air handler. We're going to put 24 volts on one of the other speed taps, or we're going to put it on like speed tap number 4, for instance, and we're going to measure the airflow and see what our airflow is. Now, we always want to set our airflow up to 400 CFM per ton. That's our nominal airflow, 400 CFM per ton of cooling capacity. So if I've got a 3-ton unit sitting outside on this normally closed contact, we're going to want to select a speed tap on that motor that's going to give us 1200 CFM on a 3-ton unit. If we have a 2-ton unit sitting outside, we're going to have it set on 800 CFM and so on. So our initial airflow setting should always be 400 CFM per ton of cooling airflow at 100% airflow. So if we got a 3-ton unit outside, like I said, we want to make sure we have 1200 CFM on that 100% cooling airflow tap, whichever one we select for 100% cooling airflow. That goes to the normally closed contact on the relay. On the normally open contact on the relay, we're going to go over to the ECM motor, and we're going to select a speed tap that's going to give us about 60% airflow, 60 to 65% airflow. Now, I've had some questions on this from customers, and they said, "Well, Joel, I'm kind of stuck in the middle. I can either my ECM motor with my ductwork and all that kind of stuff on speed tap number, let's say speed tap number 3, I've got a 72% airflow, and on speed tap number 2, I've got 58% airflow. Which one do I take?" Well, team, get as close to as you can to about 60%. 60 to 65% is the range. But if you were to squeeze down to say 58% or 55%, or used to squeeze up to 68% airflow, you get the idea. So try to stay around 60% airflow on that low airflow, because what's going to happen if you're around 60% airflow and the outdoor unit commands to reduce airflow, we'll show you how to do that here in a minute with the S1 input from the outdoor unit. But if we're around 60% airflow, we'll have nice humidity control. And as the outdoor unit modulates down and we have reduced capacity, we're going to match or closely match that reduced capacity with less airflow inside. So if you had, depending on the area of the country, and if you're in a real humid environment and you have to select between a 70% airflow or 55% airflow, take the 55% airflow if you're in a humid environment. You get the idea, because remember, if the airflow comes down, you have more humidity control. So just make those decisions when you get out there on site. Any questions or comments on how we're wiring up the relay and the low voltage wiring on this block diagram before we show you a quick animation and show you how that relay works to reduce airflow. Any questions or comments on the low voltage wiring?
Joel, normally closed, what was the airflow?
100%. Good question. So on the normally closed contact, we're going to select a speed tap on that motor to provide 100% cooling airflow. Good question. So real quick, so as you can see right now, if I was to energize the thermostat, that normally closed contact, I would automatically get 100% airflow with that relay just sitting there. Good question. All right, so at this time, let's go ahead and do that animation. Let me do that one more time. Watch the screen closely. When the outdoor unit is calling for reduced airflow, bang, it's going to generate an S1 signal. It's going to energize that relay, and it's going to switch that relay, and then we're going to close the normally open contacts when we switch that relay, and we're going to command reduced airflow. So once the outdoor unit sees that there's a capacity reduction going on, and it starts screwing the capacity down on the outdoor unit, it'll generate an S1 signal, energize that relay, and we'll go to the lower airflow. Now remember, on the normally open contact, we want to be around 60% airflow on the normally open contact. So select an airflow that's going to give you about 60% airflow whenever we get that S1 input from the outdoor unit. Any questions or comments on that little animation and how that relay is working to reduce airflow when the outdoor unit commands it? Make sense? All right, well, let's continue with our training then. So you'll notice that in this example here, I went ahead and put the W1 wire back in. So if you do have a W1 call, even if you're in reduced airflow, if you do have a W1 call, remember we're going to energize the number 5 speed tap on that ECM motor with an auxiliary heat call or a defrost call, and the fan will go on up to a higher airflow. Another way to think about it is that even if we have an S1 input from the outdoor unit and we call for auxiliary heat, that ECM motor, it's always going to be designed to where if it has more than one command, let's say we have a 60% airflow command, then all of a sudden, bang, we have an auxiliary heat command. It's going to always take the highest of the commands it's receiving. So if that ECM motor has 2 or 3 commands, for different speeds, it'll just automatically take the highest speed that it's commanded. That's called airflow priority. So even if you're in reduced airflow with an S1 call from outside, like we were showing you a second ago, if it calls for auxiliary heat, bang, it's going to go to speed tap number 5, and then basically ignore those lower speed commands, because it always takes the highest airflow command that it's receiving. In addition, just please remember also that W1 will be present with the thermostat auxiliary heat call or during the defrost cycle. So if the unit's running in lower airflow, then bang, it goes into defrost. It's going to take that airflow on the indoor coil up to our speed tap, like number 5, our high airflow during defrost. Any questions or comments on the animation and those little considerations when you're looking at an ECM motor with multiple speed taps? Any questions or comments? Okay. Well, team, the next thing we're going to talk about is we're going to talk about utilizing the HMH heat pump in a dual fuel application with a standard ECM furnace. And so basically you're going to notice that the block wiring diagram is going to be very, very similar to what we just talked about, but we're going to literally go over it wire for both single stage and 2-stage heat pump. Single stage and 2-stage furnaces with our HMH heat pump. Now we're going to continue to use that wiring accessory, that single pole double throw relay in the indoor unit for airflow reduction. And again, that kit number 001 is going to be recommended for convenience and supplied parts. Now remember, on the heat pump thermostat, you have to have that BO selection for reversing valve operation. In addition, if you're going to be doing a dual fuel, in other words, you're going to be marrying this heat pump to a furnace, you're going to have to select a heat pump thermostat with dual fuel function whenever you use it with a furnace product. So that's not a big deal. It's not a huge deal. Just please remember that your heat pump thermostat has to be a dual fuel thermostat with a furnace, and it has to have that BO selection so we can energize that B terminal in the heating mode of operation on the heat pump. As we take a look at it, there's that relay, and we're looking at a TME single stage furnace. This could be a TM9E or it could be a TM8E, either one. They use the same control board. And please remember, it has to be dual fuel thermostat if you have it hooked up to a furnace. But just like before, B is going to go out from the thermostat right out to the outdoor unit. That's going to energize that reversing valve in the heating mode when we're in the heat pump mode. Because this is a single stage furnace, we don't have a W2 input. So on our thermostat, we're going to take W1 from the thermostat to just plain old W terminal on the furnace. And by the way, the furnace has hard physical screw terminals that you'll have screw terminals on the furnace. So W1 from the heat pump thermostat to W on the furnace, because it's a single stage furnace, to W outside, so we can bring on the furnace during defrost from the outdoor unit whenever we go into defrost. That Y terminal is going to go outside just like it did before from the thermostat to the outdoor unit. C is our 24-volt common, just like we had before. This is probably looking real familiar to you because it's the same type of wiring, except we're doing it on a furnace now instead of an air handler. R is 24-volt hot. It does not go outside. E is our fan call, just like we had before. Now, as we hook that relay up, remember, team, we're going to be going from one side of the relay up to S1 so we can have that airflow reduction. So we go up to S1 on one side of the relay coil. The other side of the relay coil is going to hook to 24-volt common, so that'll complete the circuit for the relay coil itself. And just like we had before, the common terminal of the switching contacts, the common terminal of the switching contacts is going to go up to Y terminal. So basically, anytime we call for cooling operation, or more specifically, anytime we call for compressor operation, we'll have voltage right there on the common terminal for the switching contacts. The normally closed contact on the relay will then go up to Y/Y2. That's going to be our high. That's going to be our high speed or high airflow point. And then our normally open will go up to Y1. Now, please notice something, team. On the TME furnace, even though it's a single stage heating furnace, I didn't know if you do this or not, but the TME single stage heating furnace actually has 2 stages of cooling capability. So that's why we have that Y/Y2 and a Y1 point on the terminal board, is so you can actually select off the control board a low speed airflow and high speed airflow. And again, we're going to want 100% airflow on the normally closed contact, that Y/Y2. We want to make sure and select on the control board for our high cool on that normally closed contact. And then on the control board, we also have a spot that we can have reduced airflow for what they call low cool, and be sure and select a speed tap that's going to give you about 60% airflow on that low cool. So you'll notice that it wires just like the previous product on the air handler. It's just now we have hard terminals and they're labeled a little bit differently than we had on our air handler, but it's essentially the same thing. Any questions or comments on how we're going to wire this up on a TME single stage furnace if we're doing a dual fuel application? Everybody good? Okay, so keep exactly what you've done right there. And it's the exact same wiring that we did before, the exact same wiring on a TMY furnace. Now, the TMY furnace, the only difference between a TMY and a TME furnace is the TMY is a 2-stage heating and 2-stage cooling capability. So we're going to keep the low voltage wiring exactly like we had it before. And please note the TMY furnace low voltage wiring and relay, it wires exactly like the TME. The only exception is the TMY is a 2-stage furnace and requires a W2 and a W/W1 terminal. So let's go ahead and hook those up for you real quick. And we see the W2 from the thermostats, our 2nd stage heat command goes from W2 to W2 on the furnace. And then our W1 on the thermostat goes to W/W1 on the TMY furnace, and then straight outside for our 1st stage auxiliary heat and during defrost. And that's correct. The furnace will be in 1st stage heat during defrost. Now, as we take a look at this animation, we see that when we energize S1, just like we had before, we switch that relay. And when we switch that relay, we then go to that reduced airflow, which is in this case Y1 on our TM furnaces, our ECM motor furnaces. So same routine before. Remember that S1 is an output, a 24-volt output from the outdoor unit to switch a relay to command reduced airflow on the indoor product. Any questions or comments on how we're hooking these products up utilizing that relay kit and the logic of that relay? Oh, by the way, while I'm on this line of thinking, if you take a look at that outdoor unit, unlike some heat pump products, to get full functionality on the indoor product, we only need 5 wires outside. Go ahead and count them. 1, 2, 3, 4, 5. B, S1, W, Y, and C. And so the outdoor unit actually wires electrically like a single stage unit with just a Y input. And then we have that S1 output. So when you take a look at that, that's pretty unique to have all that functionality with just the simple 5 wires going outside. Any questions or comments on our low voltage wiring on our products that we've talked about so far before we get into variable speed air handler and a variable speed furnace? And we're also going to have a little session, talk a little bit about some airflow considerations as we start kind of winding down our training when we start getting to that point. But any questions or comments so far on our low voltage wiring that we've talked about and the application of that relay so far? Any questions or comments? Okay, well, good, fantastic. Tony, everybody, Tony, everything's still sounding good. I haven't lost anybody, have I?
Yep, good to go, Joe.
Okay, sounds real good. Hey, team, at this time, we're going to go ahead and jump into an AVC air handler, which is a variable speed air handler. And we're also going to talk about a variable speed furnace. Now, we're going to get into those low voltage block wiring diagrams just like we did before, but there's a couple things I'd like you to please note. The terminals that are not going to be used for the HMH outdoor function are not going to be covered. Now, what I mean by that is this. If it doesn't have to do with the outdoor unit in this training session, we're not going to talk a lot about them. Some examples would be like the HUME terminal on the furnace, or the air handler, or the DHUME terminal, or the electronic air cleaner, the EAC terminals. That has nothing to do with outside. So to keep things simple on our simplified block wiring diagram, we're not going to talk about the DHUME terminal on the indoor unit or the HUME terminal or the EAC terminal because it has nothing to do with the function outside. So to keep that simple. Now, it should be noted on any, please write this down or put this in your hip pocket. On any variable speed product, one more time, on any variable speed product, you're going to have to use that wiring accessory kit 002, that HMH7AK 002 kit, because it has 2 relays on it, and they're going to be mounted on the board, and they're going to be designated RV and S1. And that 2 relay kit has to be used on variable speed. Now, we're going to recommend the kit again for convenience and supplied parts. Now, the burning question. Well, gee whiz, Joel, I can't get the 002 kit. They're out, and we need to hook these units up. What do I do? Take 2 peanut relays. Just take 2 common little relays with 24-volt coils, single pole, double throw relays, and your own biflow filter dryer. Now, remember, if you make up your own kit, you're going to have to field fabricate some wires, with some spade connectors on them, some low voltage wires down to the ECM motor and all that kind of stuff. But in a pinch or in a bind, the contractor can still put these in with just a couple peanut relays and his own biflow filter dryer. And so by all means, we recommend the kit for convenience and supplied parts, but you're not stuck with having to have this kit to install them. All you need is a couple relays, 24-volt coil, and a biflow filter dryer. Now, please remember, a heat pump thermostat with a BO selection is going to still be required for reversing valve operation, and we're going to also have to have a heat pump with dual fuel function if you're going to use it on the furnace product. So let's start out with the AVC air handler. We're going to just presume that you're going to have a 2-stage heat strip in there. If you only have a single stage heat strip, then you'll just use the appropriate terminals, but we're going to go and utilize a 2-stage heat strip just for fun. And we're going to take that B terminal straight outside, just like we did before. Nothing changes. The only difference between the low voltage wiring on this product is the fact that we do have an O signal, an O terminal, and we have that RV relay we're going to have to deal with. W2 is our second stage auxiliary heat, just like we had before. W2 from the thermostat to the indoor unit. W1 is from our thermostat. We go to W1, our first stage auxiliary heat, and we take it right outside to W, because remember, team, that's going to come on during defrost as well. Our Y terminal goes outside, just like we had before, our compressor call. C is our 24-volt common, and that goes all the way through from our thermostat to the indoor product to the outdoor unit. R is 24-volt hot, and even though this is a variable speed product, team, remember, we do not take R outside on the HMH7. That's just a thing to remember. We don't take R outside. It doesn't need the R terminal outside. G is our fan call, 24-volt fan call from the thermostat to the indoor unit, calling for fan. Now, as we start hooking these relays up, we're going to take one side of both relays. We're going to take one side of both relays to 24-volt common. On the S1 relay, the relay on the right-hand side, that's going to go up. S1 relay is going to go up and hit the B terminal is going to hit, or the other side of the relay coil is going to hit S1, just like we had before, because we're going to energize that S1 relay for airflow reduction. We're going to take the common terminal of the switching contacts and hook that up to W. To hook that up to Y, just like we had before. The common of the switching terminals goes up to Y, just like we had before. So anytime we have compressor operation, we'll have voltage on the common of the switching terminals. The normally closed contact on the S1 relay goes up to Y/Y2 for high-speed airflow. Normally open contact on the relay goes up to Y1 for low-speed airflow. So this looks real familiar to everybody, because this is what we've essentially done with every single relay scheme that we've looked at so far for switching our low airflow. We're going to do the same thing on the variable speed air handler. But now that RV relay, that's a little different thing. What we're going to do, we're going to take the other side of the relay coil. So one side of the relay coil on the RV relay goes to common. The other side goes up and grabs the B terminal, the B wire going outside for the reversing valve. So the relay is just sitting here in the cooling mode doing nothing, but when we go in the heating mode of operation, we energize the B terminal on the thermostat. We're going to energize, and we're going to click that relay, that RV relay. Now watch this. The common switching terminal, the common terminal for the switching contacts goes up to Y on the RV relay as well. So anytime you have compressor operation, you're going to energize that common terminal for the switching contacts. Now on the normally closed contact on the RV relay, that goes up to the O terminal. So you're thinking right now, well, so what's the big deal? We're energizing the O terminal anytime we have a Y call on the thermostat. For compressor operation, we're energizing the O terminal as well in the cooling mode. That is correct. It's very, very important that we remember, on a heat pump application on a variable speed product, we have to tell the indoor unit on a heat pump it's in the cooling mode of operation, and we tell it that by energizing the O terminal. Now remember, on all of our other Champion product, we energize the O terminal in the cooling mode of operation. But on this product here, the default is cooling. So anytime we're in the cooling mode right now, you can see through those normally closed contacts on the RV relay, we energize the O terminal. So the O terminal on a heat pump application on an indoor variable speed product, that O terminal has to be energized in the cooling mode of operation for some advanced functions like dehumidification, cooling, dehumidification. And for the cooling on delay, that ramping operation that we have on our cooling on delay operation on the variable speed product that you set up on your board. And so but it has to have that O signal to make that happen in the cooling mode. So the indoor product has to know when the heat pump is in the cooling mode. Now, what happens when we go into the heating mode of operation, when we energize the B terminal from the thermostat for the reversing valve outside, when we energize the B terminal, we're going to switch that relay and we're going to break that O signal, telling the indoor unit, hey, we're in the heating mode on this heat pump. And that is correct. So we have to have that capability to energize and de-energize the O terminal during heating and cooling operations. So team, the only reason that RV relay is there is to ensure that the O terminal is energized in the cooling mode, and then the O terminal is de-energized in the heating mode. That's the only reason that RV relay is there, is to operate the signal for the O terminal on the variable speed indoor product. Any questions or comments so far before we do a little animation and show you how all this stuff switches and hooking it up to a variable speed furnace and all that kind of stuff? Is there any questions or comments so far on how we wired up these two relays? Everybody good? Okay, well, let's continue then. Let's say we have a variable speed furnace, I want to stress it wires exactly like a variable speed air handler. So there's nothing different. You have to have two relays. You've got the RV relay, you've got the S1 relay. Everything wires exactly the same. It's just that you'll notice that the terminals on the furnace are labeled slightly different. So you'll see like a W2 and a W/W1 on the furnace. So they're a slightly different labeling, but it wires exactly like the variable speed air handler. So let's go ahead and remember something. The TMV furnace requires a dual fuel thermostat. We said that before, but just remember, any furnace product, you have to have a dual fuel capable thermostat if you're going to marry that heat pump to a furnace. Now, as we come in here, let's take a look at some animations. Let's take a look at our airflow animation first, our airflow, reduced airflow. So just like before, when we energize S1 outside for reduced airflow, we click that S1 relay inside. The contacts shift to low speed airflow. So that's the relay logic for the reduced airflow on our variable speed product. Now watch this. On the RV relay, look what happened. Notice the RV relay switches with a thermostat B terminal energized. So anytime we call for heating on the heat pump, we energize the B terminal, we switch that RV relay, and we break the circuit to the O terminal. Let me back that up one more time. Watch that animation right there. So we energize the RV relay in the heating mode of operation, and we break that O signal. We take the 24 volts off that O signal. So now the indoor product knows we're in the heating mode instead of the cooling mode. That's the only reason that RV relay is there, is to tell that variable speed indoor product we're in the heating mode of operation when we break that relay or that RV relay and we energize it with that B input for the reversing valve up above. Any questions or comments on the relay logic and how we're wiring this up on variable speed products? Any questions or comments? Everybody good? Okay, team. Well, some final things as we kind of start wrapping the program up a little bit. I want to please remember to remind everyone to please, on every install, to confirm proper airflow. The HMH7 is a modulating capacity unit, and nominal airflow is going to be critical. So please size your ductwork to provide 400 CFM per ton of total cooling capacity. So if I've got a 2-ton unit setting outside, I need 800 CFM of ductwork capability. If I've got a 3-ton unit setting outside, I need 1,200 CFM and so on. So 400 CFM per ton of total cooling capacity. So this is very, very important. Now, one of the reasons we have to remember this is on modulating units especially. Airflow is so important on every unit. But on modulating units, and this is just a general statement for any modulating piece of equipment, especially the HMH7, because it has multiple sensors on the refrigeration circuit. It's looking at suction line pressure. It's looking at suction line temperature. It's looking at liquid line temperature. I think it even looks at discharge line temperature and outdoor ambient temperature. So it's taking all those temperatures and information, and it's figuring out where it needs to be for capacity modulation. And so when it's really hot outside and, a lot of load on the unit, it's at 100%. And as it starts getting cooler outside and the indoor unit, the indoor evaporator starts cooling off and the suction line temperature starts coming down, and et cetera, it starts modulating down. So think about it for a second, team. What if I had really lousy airflow? And we'll just presume the unit's properly charged and we have really bad airflow. Maybe grandma throws a rug over the return air, whatever. And we start we have poor airflow on the evaporator. And so for whatever reason, we have bad airflow. The evaporator starts getting cold, maybe even starts wanting to ice up a little bit. Well, the system outside is going to sense that through all of its sensors, and it's going to start reducing capacity because it sees that there's a reduction of capacity inside because the suction pressure is coming down, the liquid pressure is coming down, superheat's coming down. You cats get the idea. So the modulating unit, its reaction to poor airflow is to screw capacity down. Well, if you've got bad airflow and it's hot outside, the unit is going to sit here and try to compensate for that. But the only way it's going to compensate for that icing up evaporator, because it's poor airflow, guess what? It's going to modulate down. So I just can't stress that enough. Airflow is really important, especially on modulating units, if you want them to operate properly and at their full capacity. Any questions or comments on that? Excuse me. Everybody good?
Yep, we're good, Joe.
Some other considerations, team, is please remember velocity tables in Manual D. You'll see that Manual D, if you open up Manual D, you'll see there will be some velocity considerations for duct systems, supply and return duct. Please look at those because you'll see that, there'll be main trunk and branch duct considerations as far as velocities, recommended velocities in all of our duct components. The big thing to remember is if you do have a filter grill, do not exceed 300 feet a minute velocity across that filter grill. That's right out of Manual D. So when you're building your duct system and you're setting them up, be sure and nail that velocity where it needs to be on your duct components, as well as provide that 400 CFM per ton is recommended. So with that, team, excuse my coughing there, but with that, is there any final questions or comments? And let me go ahead and turn my camera back on. And we'll go ahead and get my camera back on, and we'll open the floor up for any final questions or comments as we kind of round out the training session this morning. So let's open the floor up for any questions or comments.
Joel, I had a couple of things to add before we open it up, and maybe this will also generate some questions. So if you don't mind.
Sure, come on.
Yeah, and guys and gals, I have shared 3 different documents on this meeting, and if you have difficulty getting those, just let me know and I'll email them to you. But I'm going to show my screen here, show you what I included. So I included the technical guide, and as you might be aware, the technical guide is really that is the pretty much all the nitty-gritty, most of the information that we give on a unit. If you go to the technical guide, you'll find just about everything that you want to know about that unit. But what we're looking at here is it's on page 18, this table 12, the heating performance data of a 3-ton unit. And I have a 3-ton unit in my home. It's been installed. It was installed in December, and I'm monitoring it very closely. I love the unit. But what we look at up north here is we look at the capacity as we start to get down into, colder temperatures. So you can see that the unit is rated here, not only at the ARI ratings, it's rated from 60 degrees down to 0 degrees. And I just took a look at this 3-ton unit. And if you look at the median airflow, and to Joel's point, if you have a 3-ton unit, you really want to shoot for 400 CFM a ton. So 1200 CFM on this is what I looked at. And so at 47 degrees with 70 degree entering indoor coil air temperature, you see that you have a capacity at 1200 CFM of 35,400 BTUs.
That's pretty stout for a 3-ton unit, isn't it?
It is. Well, and furthermore, if you can increase that airflow to 1500 CFM, so a little bit more airflow, you get 36,300 out of that unit. So, but let's just look at median airflow at 1200 CFM. Now, if you come down to 17 degrees,
which, by the way, Tony, is the other AHRI rated point. So to your point, this table covers more than just AHRI, because AHRI is 47 and 17, but track that over and let's see what 17 degrees. So what are we doing at 17 degrees?
So at 17 degrees, same CFM, same 70 degree entering airflow, you're getting 24,200. And so that is 68% of the total capacity at 47 degrees. So you're still getting 68%. Now, if you go down to 0, follow it right down to 0, same, all things considered, you're getting 17,800, which is about 50% or about half of your capacity. You're still getting at 0. And
that's amazing.
So, there's a lot to like about this unit, especially, if you're in a northern climate where that heat pump capacity, as the temperature starts to fall off, it's critically important, because otherwise you're staging in auxiliary heat. So the other thing that I included in the we stop sharing my screen for a moment here, and I'll start sharing it again.